Welcome back to our channel. Okay, today is a new start to me. Yeah, some of you say want to have some complete looks on the subject for revision. I think it's a good idea. Then you can learn it step by step, and then in the examination you get a better result, or you can get a better understanding of the subject. The first one I choose is to make a biology. Okay. It has A, B, C, D, E, okay, with section, okay. And then I will start from the beginning, A1.1 water. Yeah. So see anything you like or you doesn't like, okay, just comment down there, okay, after, okay. And then I will reflect on it, okay. It is first video. I take it as a trial one, okay. And your feedback is excellent to me, okay. I type all the thing, I draw all the graph, okay, for A1.1 water. It is SL and HL in biology in the new syllabus, the 2025 syllabus, okay. Most of them are mixed together, SL and HL, and the HL is at the last one, okay. Last section is HL, okay. There's just few of them for biology is completely SL or completely HL, okay, or mixed up, okay. But it is clear the first few point is SL and then the last few point is HL. Okay, 1.1 water. Okay, start our journey. Okay, and it belongs to a bigger unit, A1, okay, unity and diversity in molecules. Okay, A1.1 water, and I divided the section into different key points, okay, 1, 2, 3, 4, 5, 6, 7, okay. So each section, each video start from key point 1, okay. So key point 1 is a medium for life, okay. And you know water is a medium of life, okay. In daily life we observe it, so we have a concept that, okay, the first cells should be originated in water, and water remains the medium for life, okay. And we observe that most processes of life, okay, occurred in water, and water is a crucial compound consumed in organic and inorganic catabolism of molecule. Do you remember catabolism, breaking down of one molecule into two, and water is needed. And on the other hand, water is produced by inorganic and inorganic anabolism of molecule. Remember anabolism, opposite of catabolism. Okay, two molecules join together to form one molecule, and at the same time, a water molecule is released or produced. Okay, trust water is a recurring reaction substance in metabolism. Metabolism is the common name of anabolism and catabolism. Anabolism and catabolism joined together is metabolism. So keep on doing. You have to understand what is a polar molecules. Okay, what do you mean by polar molecules? Look at the diagram. Show you the best. Okay, A and B are two atoms joined by a covalent bond and becomes a molecule. And electron is surrounding it. Okay, if the electron has uneven distribution, biased to the left, and then the left will have a little bit more negative charge when we call it delta minus. Remember, this is delta. Delta is the Greek lower letter D. Okay, delta minus, it means a teeny tiny. And then on the right hand side will be a little bit lack of electron, so it is delta plus. And we said that it is a polar molecule. By convention, the polarity points from the positive to the negative. So it is an arrow pointing from the delta plus to the delta minus. And we add a line at the back. Okay, so it is an arrow and a cross drawn together. And this is the symbol for polarity in biology. In chemistry, in physics, we have different description for it. Okay. And this is a polar molecules. And water has H2O, everyone know it. And for the OH bond, okay, oxygen attract more electron. So electron is biased towards the oxygen. So oxygen is delta minus, and the other two end is delta plus. And there are two positive end, okay. So we call it a bipolar, two positive end. So bipolar molecule. In symbolic, we can write simply like this, okay. OHH, O delta minus, delta plus, okay. That's it, okay. So we look at the looks, okay. For neutral molecules, the overall charge is 0. Yes, but the distribution can be different, okay, can be uneven, okay, can be. If the electrons are biased to one side, In chemistry, we call it a higher electronegativity, right? And the electron will bias to that side. That side we have a slightly negative charges, delta minus. We use the delta, remember. Okay, and the opposite side we have a slightly positive charge, delta plus. And we said that the molecule is said to be a polar molecule. And this is a polarity, and remember this is a covalent bond, okay, between the two atoms A and B. And because it has a yes, in water molecules, okay, it's due to the uneven sharing of electrons, okay. And some bonding, later on we will describe it clearly. And the delta plus and delta minus of a water molecule, we have a bonding, we call it hydrogen bonding due to this polarity of the water molecules. And this one you have to remember. Yeah, it is a fact, okay. Water is a strong polar molecule among the other polar molecules. Water is strong, okay. So the delta minus and delta plus is quite big, okay, relatively, okay. As water has a dual polarity for the hydrogen atoms, okay, they are also called bipolar molecules. Yes, we have said that the hydrogen bonding is formed by the polarity, delta plus and delta minus, between different molecules. Now remember, it is a molecule, right? Its delta minus and delta plus by itself won't attract each other. Sorry, the distribution of electron is fixed, equilibrium there already. So low force between delta minus and delta plus within a molecule, but between molecules, yes, there are attractive force, and we call this attractive force polar bond. But this bond is not that strong as a covalent bond, so it should be brokenite. Solid line is a covalent bond, a broken line is other bond, for example, polar bond. And for the water molecule, because it's by bipolar nature, so you can see delta plus delta minus can form a network of bonding. So the bonding is strong, and this special bonding, polar bonding of water molecule, we call it hydrogen bond. Later on, we may encounter the other kind of hydrogen bond, okay? Or in chemistry, NH also have a hydrogen bond. We'll discuss it later. So hydrogen bond is a consequence of the polar covalent bonds within the water molecules. And the delta plus and the delta minus ends in different polar molecule attraction. Remember, different, okay? The same, no force, okay? Polar bond is formed between the polar molecules. And polar bond is weaker than covalent bond. Of course, it can be broken. So it's a broken line. So a polar bond is represented by strict broken line. And water molecules are strongly polarized. So this, if the water ones are broken line are very strong amongst the broken lines, amongst the polar bond, okay, but still weaker than covalent bond. The polar bond between water molecules is very strong, and this strong polar bond we call it hydrogen bond. So hydrogen bond is a kind of polar bond, but a strong kind, especially for water. Later on, you have another categories. Also have a hydrogen bond, and the delta plus and delta minus are within one polar molecules won't attract each other. No. The distribution I've said is equilibrium within a molecule already, so they don't change equilibrium. So low polar bond is formed within the same molecule. They are connected by covalent bond, not polar bond, within a polar molecule. So distinguish them. Remember, so when drawing a diagram with a hydrogen bond, the covalent bond is solid line, the hydrogen bond is broken line, but sometimes in the exam you want to get the marks, you need to label them. If you don't label them, you can't get the marks. So remember, when you said they joined by a solid line and broken line appears together, remember, label the solid line covalent bond and label the broken line hydrogen bond, okay? Okay, we are talking about another property of water, cohesion of water is as a cohesive property. What is cohesion? Okay, remember all the property described later come from the strong polarity of water. And what is a cohesion? Cohesion is the attraction among same molecule, same kind of molecule. So water attract water. Okay, we call it polar molecules. Okay. And then a cohesion is the attraction among the same kind of molecules. Okay, water molecules form hydrogen bond by themselves. So water is strongly cohesive because of the hydrogen bond, so very strongly cohesive. Transport of water under tension in xylem. In the xylem, water transfer is under the cohesion of water. And surface tension of water is also due to the cohesion of water. So on the surface, okay, the water molecule join together strongly, so other particle can't move inside so easily. So we have a surface tension. And surface tension makes water suitable habitat for organism too. Yes, yeah. So some some insects can walk on the water surface and then becomes the habitats for the insects. Okay. And adhesion of water is another concept. Okay, adhesion of water is the attraction between different molecules. Remember, different is adhesion, the same is cohesion, right? So adhesion is the attraction between the different kinds of molecules. Water can do it too. Be careful. Remember hydrogen bond, right? Water molecule can form hydrogen bond with other polar molecules or other molecule. We call it hydrophilic. So all the hydrophilic molecules form hydrogen bond with water. Definition: hydrophilic. The other kind is hydrophobic. We will talk about it in next section. Okay, water is strongly adhesive. Okay, water can stick to other polar or hydrophilic molecules strongly. So water is a good solvent for hydrophilic or polar molecules. Okay, remember what is dissolve? The solvent breaks the bond between the solid. Okay. So because water can form strong bonding with hydrophilic or polar molecule, they can break the bonding within the hydrophilic or within the polar molecules and form bonding with them and dissolve the hydrophilic or polar molecules. And for example, glucose. Capillary action in soil and in plant cell walls uses the adhesion of water. So sometimes they will transfer the thing within the cell wall, plant cell wall, by the capillary effect. Okay, capillary effect is the water has a strong attraction between the wall of the capillaries and it can move up along the capillary. So we use the adhesion. Remember, easy to remember. Water with other, adhesion. Water with cell, cohesion. Key point. Okay, next one. Okay, solvent property of water. Okay, hydrophobic and hydrophilic substance. Remember, hydrophilic attract to water, forming hydrogen bond. Hydrophobic, for some reason, repelled by the water molecule. This is the definition. You need to remember. Easy to remember. Phobia. Hydro is water. Hydrophobic substance is a phobia to water. So hydrophobia. Easy to remember. Okay. So by the hydrophilic property, molecules are dissolved in water. Yes, I know it. So on the opposite, by the hydrophobic property, water stays as a droplet on a lily pad because the lily pad is hydrophobic to it, on the surface. And small insect, the feet of the insect is also hydrophobic to water, may stand on water. So remember it, hydrophobic, hydrophilic, good way to explain the thing. Saccharides, the sugars have a lot of hydroxide groups, and this hydroxide group form hydrogen bond with water. So saccharides or the sugar, most of them are hydrophilic. And what are the hydrophobic thing? The fatty thing, the fat. So in general, the lipid and the fatty acid are hydrophobic, repelled by the water. But in some cases, they may have a big molecule. They may have a part is hydrophobic and a part is hydrophilic, and this is an important property. For example, for the phospholipid, it has a phosphate head, and this phosphate head is hydrophilic, love water. But for phosphophilic has two long tails, and these two long tails are hydrophobic. So the head is hydrophilic, and the tails are hydrophobic for phospholipid. Later on, you will use this special property. You encounter later. And then moreover, some amino acids, amino acids join together to form protein, right? But some amino acids are hydrophilic. Maybe they're hydroxyl group. And some amino acid no hydroxyl group, so it's hydrophobic. So a protein may be hydrophilic or hydrophobic because it has different parts. Some part of the amino acid hydrophilic, some are hydrophobic. So mixture can happen. So this separation is not so clear. For protein, phospholipid, mixture. And then water as a solvent, we have discussed it. Of course, besides just not just polar molecules, okay, the slightly negative oxygen in water, okay, can be attracted by positive ions, right? And the slightly positive hydrogen ion can be attracted to the negative ion. So ionic compound also can be dissolved by water, right? Because they can form a strong bonding with water. Water can break through their bonding. So, for example, sodium chloride, a common salt, okay? And a wide range of hydrophilic molecules that dissolve in water, of course, forming hydrogen bond. And most enzyme, remember most, so how about the enzyme? Enzyme also hydrophilic because the enzyme catalyze a reaction in aqueous solution. So enzyme itself has to be dissolved in water too. So most enzymes are also hydrophilic. Okay. On the contrary, the function of some molecule in cells depends on that they are hydrophobic and insoluble in water. We'll encounter this later, for example, the fats, the lipid. Okay. So remember hydrophilic, hydrophobic, big concept. And transport in blood, okay, blood has a lot of water because a lot of things can be dissolved in water, right? So the solvent properties of water link its role as a medium for metabolism and transport in plants and animals. So blood has a lot of water. This water helps to transfer the water-soluble molecules, for example, carbon dioxide, oxygen, glucose, amino acid, and sodium chloride. But you remember there is something that is insoluble, but also transferred by blood, right? So, for example, cholesterol and fats, they have the blood. The other 10% has to have some property to transfer them to, okay? And we found it, okay? For the cholesterol and fats, okay, it is transferred by lipoproteins, okay, complex inside the blood, okay? So remember, both are transferred. Water transferred the soluble one, and the other one is transferred by the lipoprotein, okay? Wow, thermal properties of water, physical property, we call it a thermal property. Thermal property is one of the physical property. And physical properties of water have a wide range, okay? For example, buoyancy, uplifting force, viscosity, thermal conductivity, and specific capacity. In this part, we talk about the thermal property, okay? Specific capacity, do you remember it? Yes, it is a heat energy required to raise the temperature of a 1 kilogram substance by 1 degree Celsius. Similar, this is the point, okay? Don't talk about other subjects, okay? Just I want to similar to enthalpy. Enthalpy in chemistry is of 1 mole, okay? And in this part, specific capacity is 1 kilogram. A little bit different, okay? And the higher the specific capacity, need more energy to rise its temperature, the more energy are required to raise the temperature. So the temperature can be more stable. And the other concept, specific latent heat of vaporization, vapor, make the thing become vapor, is the amount of heat energy required to vaporize 1 kilogram of water. And all these two things is bad for water because of its strong hydrogen bond. So the higher the specific latent heat of vaporization, the more the energy needed to vaporize water. And water has a strong polarity. So water forms strong hydrogen bonds by themselves, so it's hard to change their properties. So it is hard to raise temperature of water. It is also hard to vaporize it, okay? You know, vaporize means what? Breaking the bond, right? Even hard. So remember, hard to raise the temperature, high specific capacity, hard to vaporize it, large high specific latent heat of vaporization. One is a 4.2 kilojoule and one is a 2,260 kilojoule for 1 kilogram. Big number. You can Google. Compare with either thing. These two are exceptionally high value for water, specific capacity, and also specific latent heat of fusion and vaporization. For example, we compare water and methane. Methane is CH4, but methane is non-polar. Water and methane are similar mass, okay? 16 grams and 18 grams, similar molecular mass, okay? But methane is non-polar. So everything more methane is low. Everything. Melting point, boiling point, specific capacity, specific latent heat of vaporization, everything is low. Just can be explained by one thing. It is non-polar. It doesn't form polar bond. Water is polar, strong polar, form hydrogen bond. Okay, that's the difference, okay? Remember it. And water is a coolant because so for example, everyone know in sweating, okay, but now we have to explain sweating by them scientific terms, okay. Water has a high specific heat capacity and high specific latent heat of vaporization, right? So when the sweat evaporates from your skin, okay, it takes away a lot of heat energy from you, okay, and this heat energy is used to break the hydrogen bonds between the water molecules, so release a lot of heat from you, okay. As water is a solvent, okay, be careful. And sugar, amino acid, protein, hormones, a lot of ions are dissolved in water in our body. So they can come out as sweat too. So when the sweat water evaporates, this thing solid remains on the skin. Okay, what are the benefits of water? Remember, it's a summary. Cohesion of water, okay. Transport water from the roots to the leaf along the xylem, we'll talk about it later. And the cohesion of water, making it at a high surface tension. And small insects may walk on water, it makes water surface a habitat for them, okay. And adhesion, the attractive force between water and the wall of the plant, okay, can keep the leaves moist and then transfer the thing up, okay. And the high specific capacity and latent heat of vaporization of water and make it a good coolant to regulate and modulate the temperature, okay. And the earth, the whole earth temperature and the power plants, okay. And mammals always use water as the coolant, okay, not just us, okay, the whole earth, because we have water, so our temperature are more stable. When the sun shines on us and the sun doesn't shine on us every 12 hours, right? But our temperature is stable. For example, sweating in mammals take away a lot of heat, okay? And water also has a high boiling point, okay? It can change its, there's a wider range of temperature, and it can freeze in cold weather. So water is a suitable habitat for marine organism, okay? And you can see that the animal live in water and animal live in land and air are completely different. For example, the seal and you. Don't talk about other things, long, tiger, lion, okay? The seal and you are completely different, right? Because we live in, they live in water, we are not, okay? Wow, AHL, just two viewpoints, okay? Additional high level. One is we are looking for extra-planetary origins, okay, of water. Where does the water on Earth come from? Why the moon doesn't have it, okay? First of all, we have a hypothesis, only a theory, okay? They said that water-rich asteroid from the outer space collide with the Earth, so they bring a lot of water. The whole Earth's water come from them, okay, and form the ocean and the abundance of water over millions of years, and the Earth's history are evolved from it. But it's just a theory. But the Earth is something stronger than the Moon. Okay, we have a greater gravity. Remember, the gravity of the Moon is just 1/6 of the Earth, right? So the gravity of the Earth is big enough to retain the water, and on the Moon can't. Okay, so the Moon loses all its water if it has before. Okay, it should have some before. Maybe frozen, right? And also the low temperature of the Earth keep the water in a condensing situation, not vaporize and become gas and fly away. Okay. So we are looking for Goldilocks zone. So remember Goldilocks story. Porridge, not so hot, not so cold, medium. It is this concept, we call it Goldilocks zone. Okay, we are always searching for extraterrestrial life. We find our friend, okay, in the space. Okay, we don't want to be alone in the space. Okay, so but we found that the orbiting distance of the Earth from the Sun is just right for water to remain in a condensing as water, so water can exist. So this decision is important. We call it a Goldilocks zone. And this is a habitable zone. Okay, so we search for extraterrestrial life. We don't need to look at all the planets, just the exoplanets. Okay, just the outside the solar system's planets. Just look at those that are rocky and at the Goldilocks zone. So level down, not so many. You know, many star planet outside. Right? We just level down the candidates. Okay, and the water is more likely to be found in these exoplanets. Oh, thank you. We finished the first one. Okay. So comment down there to see how can I improve. Okay. Thank you. See you.